In this video, I'm going to build this symbology for orienteering maps inside QGIS. Okay, so for this episode, I'm going to take a look at orienteering, and this is a great form of exercise, be a part of nature, and you combine it with maps. So for a GIS person, it's an excellent way of exercise. And if you're interested and want to know more about orienteering, there are international organizations that are devoted to orienteering. So I won't go into any details, but my primary focus here is to see if we can create maps in QGIS that can be used for orienteering. And I'll get back to that in a minute. First of all, there are commercial software that creates these orienteering maps and the courses that you use in your competitions and trainings and so on. They are quite excellent, I'm told. I haven't used them myself, but they are proprietary. So most clubs and events in orienteering actually do use this software, but it comes with a cost. And they even started a subscription way of licensing the software. So this is something I really dislike with the software when they go to a subscription-based licensing model. Anyway, there are still old versions of OCAD software that you can purchase and use. And there are free viewers as well. Anyway, there is an open source alternative called Open Orienteering. And they have quite a bit of new functions in their latest updates. So it is useful to create your maps, and there's even an Android app that you can use in the woods when you're mapping or creating your features that you can use in your map. And it's available for Linux, Mac OS, and Windows. We can take a look at it. So it's a simple interface, and you create a new map. And this is the benefit compared to using QGIS, for instance. Everything about orienteering is built in. You don't have to comply to a certain standard because it is already built in. You don't have to adapt anything. So if you are serious about orienteering and your orienteering maps, I would suggest you start by looking at this software and not QGIS. But since I'm using QGIS and we could look at this as an exercise in symbology, I will do all the symbology in QGIS, but I'll just show you what open orienteering looks like. So you select the standard and the scale, and then you can add a template, and that is a raster image, for instance, that you have scanned or downloaded or in some way. And then you get all these objects that are according to the standard. And if you want to, if your map are all done like this, you can just add your course. And it's as simple as selecting the course, setting your starting point, adding your controls, like that. And there you have your orienteering course. And then you can add your control numbers and any additional information and print your map. I'm not quite sure how import and export of geospatial data works, but I know that you can import shapefiles, for instance, and GPS or GPX files. So if you are serious about orienteering and want to use open source, this is the software for you. But I'm using QGIS, and for that I need to know how the symbology works. And then there is this standard, the International Specification for Orienteering Maps. And there are several versions. So let's see. For instance, we have definition of the colors. I'll get back to that. Let's see, I think it was page 35. And this is what we are going to focus on in this episode. Overprinting symbols, the course that you saw earlier in Open Orienteering. It's very exactly defined, and all the symbols are very nicely defined in this standard. So if you want to create orienteering maps that conforms to the standard, you absolutely can. But back to the standard. Some important things. According to the standard, every symbol size should be at this scale, 1 to 15,000. So I will do most of my measurements in map scale or to scale, and not in centimeters or millimeters. I think that will be easier. So we need to have a starting symbol and control points, intermediate lines, and a finishing point. And there are more complex symbology, like these finish lines, or a lot more options, but I'll stick to as simple as possible. So let's start QGIS. Here I have an orienteering map as a background, and I will create a temporary memory layer, or what's it called in English? Course. It should be a line. Yep. And let's just pick a course. Start there. There. Yeah, that's okay. Let's just make it thicker, like that. So that is what we have to start with, a simple line. And I think I'll turn the background off for now, so it's a bit easier to look at. One thing I want to fix right away is the coloring. So in the standard, we have the color right here. I could type that in, but the standard specifies CMYK color, and QGIS uses RGB. So I think the simplest way is just to pick this. So we'll just pick it. No, can't do it like that. I need to do it like... pick. Okay. I think that's, oops, good enough. And that color, I'll copy that as well. So it's always there. Okay. Where to start? If you look at the course or the symbology, we need to break it down. We have one symbol for the start, and it's only at the start. We have one symbol at the end, and it's only at the end. Then we have one symbol for each vertex or point in the line, and they are only there, not at the start or the end. And then we have the line that ties them together, and it doesn't go all the way to the points. It ends outside the control symbols. And that is actually quite a bit of problem for QGIS. But I've tried it, and it is possible to fix. So I think we will start with the easy ones, and that's the start and end points. So we will add a symbol layer, and it should be a marker line, and it should be only at the first node, like that. And the marker should be, and now I need a calculator, and I need the standard. They should be 4 and 6 millimeters at 15,000 scale, which means 6 millimeters are 90 meters, 4 at 15 is 60. So 90 and 60. So the first one should be no fill. No, offset. That shouldn't be offset. Stop. The size should be 60. Color, like that. And the width. Was there anything in the standard about the width? 0.35. At 15, that's 525. So the width should be 525. Okay, that was the inner one, and let's duplicate that and just change the width to 90. Okay, that was the starting point. Now we go for the end point. A new marker line. Wait a minute, did I do it wrong? That was the starting point. That should be the end point. This should be the starting point. And that should be a triangle. This one, I'm guessing. And it should be $525. No fill. The correct color. And the size. Let's see. 6 at 15. That's the same, that's 90. So 90. And it should not be, this is up on the symbol, so we should rotate it by 90 degrees. There we go. There we have the start and the finish symbols. Now comes the tricky part. To do the lines, they need to start not at the center, and they should end before and start after each vertex, creating a gap at each vertex point. And that can only, to my knowledge at least, be done with a geometry generator. And that should be a line. And I think I'm going to remove... Can I just make that a geometry? And no. Yes, I could. No, I couldn't. Remove that one. So the geometry generator as a line. It should also be 525. So we need to generate a new line for each segment that starts outside the symbols and ends before the next symbol. And the outside of this symbol is 90 meters. And for the controls, they are, let's see, 5 at 15, that's 75. So let's say 100 meters before or after. You can try that first. So for each segment, we need to generate a new line. And the only way I have found that this will work is if I create a multi-part geometry as a well-known text format and then converts it back to geometry. So I will just paste my code here, and I'll try to explain what happens the best I can. So let's replace this with the code like that. So let's look at the code. This is a nice feature in the latest QGIS that you can add comments to your geometry generator. This is very useful for complex scripts like this. So this will generate a line, not quite from start to end of each segment. And it will take a text string formatted as a well-known text format, as a multi-line string, and turn it into a geometry. So that's the first part here. To get the array of line segments, we generate an array from a array to string. Wait a minute. Array for each. Okay, we generate a series from 1, and that's the first point, to the number of points, and that's the last, the number of points minus 1. Yeah, that works anyway. And for each of those generated items in the array, we should do something. And that parenthesis ends there. So everything from there to there is generated for each segment in the line. And that array that we create will then be converted into a string and added to the well-known text format. Okay, so we start the well-known text format text string outside the array loop. We add the generated array that has been converted to a string, and each line segment is generated inside this. So let's take a look at this, each line segment. First of all, we need to know the azimuth, or the direction of the line segment. And I do that by creating a variable that I called AZI. And that's basically the azimuth of the current vertex point towards the next vertex point. So the azimuth is the direction from the first or the current vertex point to the next vertex point. And we should start x meters from the current vertex, and I said 100. Like that. And we should start at the current point and project that point 100 meters in the direction of the azimuth for x and for y. That gives us this point. So from the start, 100 meters in the direction of the line, create the starting point. And then it should be drawn 100 meters short of the next point. And that is the next two lines for x and y. So for the next point, we do that 100 meters in the reverse direction of the azimuth. And we need to generate the text so that it conforms to the standard for the well-known text format for multi-line string. And all this together will then be converted back to a geometry. a bit complex, but this is the only way I have found that I can generate this type of symbology. Okay, so now we have start, end, and intermittent lines. So now we need to do the control points. And that could be a marker line. But if I do it as a marker line at each node, we also get the points at the start and then, and I don't want that. So I need to do it with another geometry generator. And it should be a point layer. And this is not as a complex code, but I'll paste it in anyway. So this is also a multi-point, well-known text formatted geometry that will be converted back to a geometry that can be shown in QGIS. It will be generated from a series, the same as for the lines. But it will not start with the first point, it will start with the second point. And it will end at the second to the last point. And it will just add a new X and Y coordinate for the current point in the array that is generated. And that gives me these points. And the marker should be transparent. It should be in map units. The size should be 525. And the color like that. There we go. And now I think that 100 meters is a bit much. So go back to this one and change it to 80. Yeah, 75 is the diameter. Okay, then I guess 60 wasn't so bad. I had that before. That's not too bad. So, there we have our course. And this can be edited like any QGIS vector object. And I could end here, I think. But I'm going to add a few things that not exactly to standard, but anyway. I want to have the numbering put out. I don't want to add that manually. So I could add that to this marker and create a second marker that is placed with the numbers. But I will instead use a separate geometry generator that is slightly different. So I'll copy my source text or source code, a new geometry generator. It's very similar to the one for the controls, but it has an addition of moving the points away from the center of each control, away from the center of the course, which should place most numbers outside, away from interfering with the course. But for this kind of area, they will be placed maybe at a bad location. Well, we'll see. So points like that. And here we see a problem, for instance. But anyway, it shouldn't be a simple mark, it should be a character marker. And this is also same color, and it shouldn't be dingbats, it should be a sans serif font, like Arial. But I want it to be a bit thicker, so I'll use Noto Sans. Does that work? Probably. And the size for text, 4. $60. And I need to move that away a bit more. So let's say 100. Yeah, that's good enough. And the character should not be just any symbol, it should be geometry part number, like that. So if I move the controls a bit, like that. And I'll add one more thing that I think is useful, but absolutely not by standard. And that is another marker. And I'll create a character marker. It should not be 60, it should be maybe 20 meters. And it should be placed offset. Too much. Maybe. And that should be the length. And it should only be the integer part. Maybe a bit bigger. And the same color. So if I make it bigger, I can draw a new course. Start here. Like that. Then I get the course length. Okay, so again, if you are serious about orienteering and want to create correct maps and so on, I would suggest that you use OCAD or Open Orienteering software for this, because it will make it much easier for you. You don't need to learn QGIS. But if you do know QGIS and want to create orienteering maps, you absolutely can do so with this type of standards document. Quite excellent document, actually. So this video is not a suggestion that you should use QGIS instead of Open Orienteering. It's just a way for me to try to see if I can find ways to replicate a symbology with the tools that are available in QGIS. And as I've shown, it is quite possible, even if it is a bit complex for some parts of the geometry. So I hope you enjoyed this video, and I'll see you next time.